Hi students, welcome to our physics class. Our chapter name is electric current and its effects. Today I am going to conclude this chapter. A few topics are there left. And in the last class we discussed about the magnetic effect of electric current. Magnetic effect of electric current. What do you mean by this magnetic effect of electric current? That means when electricity is passing through a circuit or a conductor, you feel that they're having a presence of magnet. Or we can simply say that when I am connecting a conductor with a source of electricity, that means I am connecting it with a set of batteries, what you can see that this conductor is converting as a magnet, or it behaves as a magnet. So that is called what? The magnetic effect of electric current. That is takes place in every situations that where the electricity is passing through with all the wires, it acts like a magnet, or we can see the presence of magnet and we say it as magnetic field. Magnetic field means the presence of the magnet. That is actually the magnetic field. We say it as the term magnetic field. So, around this wire we can see magnetic field is there when the current is flowing through this conductor. These are the things we discussed in the last class. Who is the scientist found such a phenomenon in such a system? The scientist called Oersted. The spelling is this: O-E-R-S-T-E-D. Oersted. We read it as Oersted. The scientist called Oersted studied about this magnetic effect of electric current. That is actually something like accidentally he found that he is sitting in the laboratory and he accidentally found that through a conductor when electricity is passing, it behaves as a magnet, and he found it with the presence of a magnet. That means the compass. Inside the compass we know that it is having a needle, and that needle is what? It is also a type of magnet, and it is needle magnet. So no need of such details. Just want to remember the name of this scientist called Oersted. He is the one who studied about the magnetic effects of electric current. Also we can say that he found that the interrelation between the magnetic effects and electric effects. So this is all about our last day's topics. Now we want to study how we can make electromagnet. For that, I want certain type of things. The things are very simple. The first one is I need a nail. The next one I need insulated wire. A key. Key means switch. And a battery. These are the things I need to make electromagnet. Our topic is electromagnet. This is actually a type of magnet, but not actually similar to the normal magnet. That means you can see magnets in the clock or the speakers, like the things, and this is something different from the normal magnets. And the thing is that they are permanent magnets. That means when they are made, they show always the properties of a magnet. But for this electromagnet, it is having certain different things will be there. Just look. We want a nail. So just take that nail. Now we want to do that. Just wind the insulated wire. Insulated wire means you can see the wires in blue color. yellow color, red color, like a plastic coating is there outside our wire. Such wires are called what? Insulated wires. Why we are using insulated wire? Because we are reducing the cause of shortage. So I am just winding this. Winding means I am just putting it like that. That means taking an insulated wire. This is a type of insulated wire. You can see black color, and this material outside this wire is non-conducting. So this winding means I am just taking this wire and putting it like this. This is what? Winding of wires. So I just take the wire which is insulated and doing that, winding it. Now I am connecting the key here. Now it is open. And then connecting our battery and completing the circuit. Simple diagram. Now the thing is that I am just taking a safety pin. I am just taking a safety pin. And observe, you want to remember, the key is open. That means the electricity is not flowing through our circuit. So now the thing is that just observe, do this is attracting the pin. Is it attracting? No, it is not attracting. The pin is not getting attracted to this windings. Now I am going to do that. I am just closing this key. I am just closing this key. Now you can see that this pin will jump to here. This pin will jump to here. That means when the electricity is flowing through this section converted to a magnet. And now I can call this as electromagnet. Electromagnet. Now still the pin is attracted to this area. Now I am going to do that. I just open the key. I just open the key. Now what you observe is that this pin will fall down. This pin will fall down. That means now this coil, we call it as, when we are winding or we are turning these wires, we call it as coil. C-O-I-L, coil. So when the electricity is flowing, then this coil acts as a magnet. And when the flow of electricity breaks, what happens is that it will go into previous stage. That means now this system is not a magnet. This coil not acts a magnet. So this is about the electromagnet. In this area, you want to remember how to construct one electromagnet. That means you have to study the circuit diagram, how to make electromagnet. That is this diagram. And what are the things we need to make such a setup? That is the thing first you want to study. And you want to remember this electromagnet is a temporary magnet. Temporary magnet. That means it is not at all magnet for all the time. And you can see when you are continuously connecting this switch for a long time, it not take too much time. This battery will lose its energy very fast. That because it acts as a magnet and it serves too much energy with short period of time. So when we are closing the key, it acts as a magnet. And when we open the key, it is not a magnet. That means there is only a temporary effect of magnet. And we call it as, this electromagnet is only a temporary magnet and it is not a permanent magnet. This is all about our electromagnet. And you want to remember what is this structure called? Coil. Now we want to study the advantages or where we are using this electromagnet. There is nothing too much complicated. Just we want to study 2-3 areas that we are using the electromagnet. Now we are going to look at. The first one is crane. In the crane, we are using very large electromagnets. Why we are using? This crane is using to take too much heavy objects. And when that object is something attracting to magnet, so we can use electromagnet to take heavy objects. That means this electromagnet is very powerful. So we use this electromagnet in crane, and such magnets are very strong. Strong electromagnets we are using in crane. The next one is doctors use these electromagnets. Where these doctors use this? That means in our eye, when sometimes some sort of very tiny iron particles and all fall, what we do is that the doctors use very small electromagnets to catch the powder of iron to be taken out from our eyes. So, doctors also use that electromagnets to take out the iron particles. Generally, the iron particle means the things that get attracted to magnets. So, such things when fall in our eyes, doctors use this electromagnet to take the particles out. And also, this magnet is very tiny magnet. And the next point is that it is used in toys. You see different types of toys are there. That means we are putting the batteries and the toys working in the batteries. In such toys, there are present electromagnets, and that's how they are working. You see the cbse and different types of toys are there. So in these all devices we can see the electromagnets. And also to think why we are using the electromagnet rather than the permanent magnet. Permanent magnet means the general magnets that we see in our clock and all. Or the timepiece, we can see certain type of black color magnets. Why we are not using that and using the electromagnets here? The reason is very simple. I will show you that we just made certain type of electromagnets, and here we connected. First I am connecting one cell and a key. I am closing, and I am taking a compass here and observing the deflection of this. Deflection means the vibration. When the key is closed, you can see that this needle gets vibrating. We say it as deflection. And now I am going to do that. I am increasing the number of cells. Now 2 cells. Now I can see that it is getting more vibrated or deflected. Again I am increasing the number of cells. 4. Now you can see it is getting more vibrated. Again I am increasing the number of cells. Then you can see the vibration is getting more and more. That means we can control the power of magnet with respect to the electricity. That means when we are giving high amount of electricity, the magnet will have very much power. And when we are reducing the power of electricity, then also the magnet will be also weak. So we can adjust the power of magnet. But for a permanent magnet, it is unable to control the power of magnet. But according to the electromagnet, it is possible to control the power of the magnet. So this is all about the electromagnet. I think it's clear for now. Now we want to study one of the device having the electromagnet inside. That is the electric bulb. In your home, you may see that having electric bulb in your home. Now we are going to discuss what is the internal structure inside the electric bulb. Electric bulb. For this, it is having a structure like said in the last section that we wind the wires. In the similar way, we can see two coils are present inside this electric bell. After that, here we have a contact screw. We have a contact screw. Contact screw. And after that, with the contact screw, we are connecting battery. We are connecting battery. And also, it is there connected to our coils. And also here we have another type of a structure present at the top, is that with the contact screw we have a type of hammer. We have a type of hammer and also a metal piece present here. Metal piece. This is a hammer. This is a contact screw. These are two coils. We have battery. And this is all about the structure of our electric bell or the circuit diagram of electric bell. Now we want to study how this electric bell works. That means when the electricity is not flowing, it is not a magnet. We already said that. But when the battery is connected to the circuit, that means when electricity is flowing through the circuit, these coils, in some bells it only have one coil, in some it have two coils. So in this we have two coils, and when the electricity is flowing through this, what happens is that this coil will turn into magnet, and this section is what? A metal piece. That means it will attract to magnet, or it is able to attract magnet. So when we switch on, what happens is that this turns into magnet. Not permanent magnet, it turns into electromagnet. Now the thing happens is that it will get attracted to this. That means it will move to this. This thing will attract to this. That means this is attached to this area, and what happens is that this will hit on this metal piece. That's how we hear the sound of bell. We get a kick sound to this bell. And this happens all when I put the switch on. When I put the switch on, then the electricity will flow through this and the circuit is complete, and this coil acts as a magnet, electromagnet, and then this piece get attracted to here and then it go to hit. Now I just take the hand from the switch. What happens is that again it will go back to the previous stage. That means when the electricity is not flowing through the circuit, then what happens? Then what happens is that it turns into the previous form. That means it lost the power of magnet at that stage. So this is the working of electric bell. Once again I am repeating, the electric bell means this is the structure for our electric bell. You just want to study this structure. And here we have two coils, and when the electricity passes through this, that means when I switch on, what happens is that the electricity will flow through this circuit and these coils turn into magnet. So that magnets attract this piece, or we can say it as it attracts the contact screw. When the contact screw is moving to the, what happens is that this hammer gets hit on the metal piece. And when we are offing the switch, what happens is that it will turn into its previous stage and it will not be magnet anymore, and then it will go back to the previous state. This is the working of electric bell in our home. I think it's clear for you. Our chapter is over here. In this chapter, we discussed about different things, basically about the electric current and its effects. That means, first of all, you want to study the different symbols of the things. That means how to draw a bulb, how to draw the battery, cell, and how to draw wires, like the things you want to study in this chapter. That is the first thing we focused. Then we want to study the different effects of electric current. That means in the first area we discussed about the electric effects or the heating effects of electric current. That means when we are giving electricity to a circuit, they produce heat. That is the heating effects. Or we discussed about the magnetic effects. That means when we are giving electricity to a device, it acts as a magnet. That is magnetic effect. And also there is having another effects like mechanical effect, sound effect, light effect, like different effects are there for our electric current. That means in all cases the electric current is converting from one form to another. That means the electrical energy is converting to light energy in some ways, in mechanical energy in some ways, in heat energy in some cases, like the things. That is the second thing we discussed in this chapter. After that we discussed about fuse. Why we are using fuse in our circuits, what is fuse, the things we discussed. After that we discussed about the magnetic effect. That is the thing we discussed in the last class and today's class. What is the magnetic effect when the electricity is passing through a circuit. Then you want to study the electromagnet. The electromagnet is very important and you want to study how to construct an electromagnet. The circuit diagram is very important. You want to study the circuit diagram. And also we discussed about the working of electric bell. This is all about this chapter. Now we want to do the problems. I will send the answers. You just want to go through that and write it in your notebook. And if you have any doubts, you please contact me. And we will meet in our next class with another chapter.